All right, ladies and gentlemen, so today we're going to talk about lesson 8.6, and we're going to talk about 8.6a. We're going to talk about the first half of it in this video, and then I'll have a new video that talks about the second half. In this first half, we're just going to be factoring trinomials when a equals 1, and that a equals 1 refers to the idea of y equals ax squared plus bx plus c, that idea of our standard form trinomial. Same skills that we've been working on, we're interpreting expressions and understanding polynomials. And our vocab terms today, the first one is the idea of factored form. So when I'm asking for factored form, I want to see the product of two or more polynomials. I want to see it split up. Typically, it's going to be two binomials with parentheses around them. The other idea is the idea of standard form that we've talked about before, where I have the expanded out version from the highest to lowest power on my exponents. The y equals ax squared plus bx plus c. So what we're going to do in this lesson is we have these two steps that we need to follow when we're trying to factor our trinomials. The first thing we need to do is we need to use that greatest common factor to undo any distribution. We want to pull out any common terms from any terms that are common to all of the pieces of our trinomial. And then, we should be in standard form at this point, ax squared plus bx plus c. I want to find the two factors of c that add up to create b. Now this seems a little confusing here. I want you to write out these steps, and then we're going to practice with this, and it'll make more sense. So, two vocab terms and then steps to follow that we should write down. When you're ready, head on to the next part. All right, so now these pre-practice problems, you don't need to write them in your notebook, but I want to talk about them here and how we would figure this out. So my first little riddle is what two factors of 12 have a sum of 8? Well, many of you can jump in right away and tell me what this is, but let's walk through the process. So I want two factors of 12. So I know that 1 and 12 would be a pair of factors. I can use 2 and 6, or I can use 3 and 4. So my pairs of factors for 12 are written here. And I want to know which ones have a sum of 8. So if I add 1 plus 12, I get 13. Well, nope, that's not going to work. If I add 2 and 6, I get 8. So my two factors that have a sum of 8 would be 2 and 6. Well, let's try it again. Now we'll think about 32. Again, I have 1 and 32. 1 times 32 gives me 32. 2 times 16 gives me 32. 4 times 8 gives me 32. And I'm out of integers that create factors of 32. Now if I go through and find the sum, well, 1 plus 32 is 33. 2 plus 16 is 18. 4 plus 8 is 12. So my two factors that have a sum, two factors of 32 with the sum of 12 are 4 and, not 8. There we go, 4 and 8. Last one that I want to think about is two factors of 24 that have a sum of negative 10. Well, that sum of negative 10 tells me that I need to have some negative numbers. If my sum is negative, but my multiplying piece, my product here, is positive, that means that both of my factors must be negative. So factors of 24, I could have negative 1 and negative 24. I could have negative 2 and negative 10. I could have negative 3 and negative 8. I could have negative 4 and negative 6. My factor pairs here, they must both be negative because a negative times a negative gives me a positive. When I add them up, well, if I add negative 1 plus negative 24, I get negative 23. Or sorry, negative 25. If I add negative 2 and negative 10, I get negative 12, negative 11, negative 10. Oh, not across there. Negative 10. My final pair here is negative 10. Negative 4 plus a negative 6 is negative 10. So my factors would be negative 4 and negative 6. Well, hold on to that thought for a second here, and we're going to do a few more pre-practice problems that you don't need to write. These ones here, if I see my factored form, I have the idea of those polynomials multiplied by each other. I have two binomials, and I can expand it out. For this first one, let's expand with an area model. We'll do x plus 5, and I have x plus 3. If I do my little boxes here, I see that I have x squared, I have a 5x, I have a 3x, and I have a 15. In standard form, when I start squishing those pieces back together, I wind up with x squared plus, well, I have a 5x and a 3x, plus 15. Now, if I think back to my last slide here with my other pre-practice problems, I had factors of 15 that add up to make 8. That 3 and that 5 are my two factors of 15 that sum to create 8. Let's try it again, this time with some subtraction. If I think about that same, or a different question here now, x plus 1 times x minus 5. This time, let's FOIL it. If I expand it with FOILing, I get x times x is x squared, x times 5 is a negative 5x, x times 1 is a plus x, and 1 times a negative 5 is a negative 5. My standard form looks like x squared plus 5x, or a negative 5x plus x gives me a negative 4x, and my minus 5 stays there. Same idea. I had factors that multiply to create negative 5 and add up to create that negative 4. If I multiply 1 and negative 5, I get negative 5. If I add 1 and negative 5, I get that negative 4. So we're taking those skills today, and now in prior lessons we used the factored form to create our standard form. Well, now we're going to work the other direction. We're going to start with standard form and we're going to end up with that factored form. First practice problem to write down in your notebook is x squared plus 5x plus 6. So I see that my product is going to be positive, so I know that my two factors are either both positive or both negative. I see that my sum is positive, so that tells me that I'm going to have positive factors. My factor pairs would be 2 and 3 or 1 and 6. If I add 2 and 3, I get 5. So I know that this one is going to be that 2 and 3 is going to be my correct pair of factors here. So in factored form, I get x, no squared, x plus and x plus, because I know that my two factors are going to be positive. I get x plus 2 and x plus 3. And now we know from multiplication that order doesn't matter. So if you wrote it out as x plus 3 and then x plus 2, that's also correct. So this is my factored form of my polynomial. To check my solution, I'm going to FOIL it back out. We could FOIL or we could area model. We'll FOIL on this one. When I FOIL it out, I get x times x times 3, x times 2, and 2 times 3. So once I've turned it back into standard form, I get x squared plus 5x plus 6, which matches my original polynomial expression. Let's try it again. This time I have 2x squared plus 6x minus 20. Well, if I think back to the steps that I wrote at the beginning of this lesson, the first thing I need to do is I need to use that idea of my greatest common factor. When I look at these terms here, I can get rid of that 2 because I see that it's a common factor with each of my terms in my trinomial. So this is going to turn into 2 times x squared plus, not a 6, plus 3x minus 10. If I pull a 2 out of each of my pieces, that's what I'm left with. And now I want to factor that inner piece. I want to have two factors that make negative 10 and add up to a positive 3. Well, that negative 10 tells me that in my factored form, I'm going to have one positive and I'm going to have one negative. The fact that my sum is positive tells me that with my two factors, the positive factor needs to be greater than the negative factor. It needs to be a larger magnitude. My factor pairs here, I can have 1 and 10 or 2 and 5. If I think about those two factor pairs, let's write them out, 1 and 10 or 2 and 5. When I think about my pairs here, I know that the bigger one is going to be positive and the smaller one is going to be negative. So these are my options. If I add up negative 1 and 10, I get 9. If I add up negative 2 and 5, I get 3. So I know that this is going to be my factor pair. So I get x plus 5 and x minus 2 as my factored form. Like before, order doesn't matter. It could be x minus 2 times x plus 5 or the way that I've written it here. To check my solution, let's do the area model this time. I'll do x plus 5, x minus 2, or x plus a negative 2. And I get, oh, let's not do yellow, I don't like yellow. Purple. X squared, 5x, negative 2x, and a negative 10. I get x squared plus 5x minus 2x minus 10, which gives me x squared plus 3x minus 10, which matches that stuff in the inside. For my true final answer here, I forgot a piece. I need to have that 2. That 2, let's copy over it in yellow. This is essential to have my factored form match my original equation. I need to have that coefficient, that greatest factor that I pulled out of each piece. So, but this piece matches that inner stuff. So my factoring on this section was correct. I just need to make sure that I include that coefficient, that term out in front. Let's try again one more time. This time I have negative x squared plus 3x plus 28. Well, in this case here, when I'm thinking about my factored form, I want to start with that idea of x squared plus bx plus c, which means that that negative needs to go away. And just like in the last example, I want to pull out that coefficient. In this case, that negative is really the same as a coefficient of negative 1. So I'm going to pull out negative 1 from each piece. Well, when I pull out negative 1 from 3, I know that this turns into a negative 3. And when I pull out negative 1 from 28, or positive 28, it turns into a negative. If I were to redistribute that negative out, it would match my original expression, so I know that I've done it correctly. Well, now let's factor the trinomial that we're left with inside the parentheses. I know I need factors that multiply to create negative 28 and add up to create negative 3. So this time, again, when I rewrite it, I'll leave that coefficient there. I have x plus something and x minus something. I know that I'm going to have one positive and one negative because my product, my multiplication piece, is negative. My sum is also negative, so this time I need to have the greater factor, the magnitude is greater, of the larger value. The larger value needs to be negative. So if I think about my pairs here, I can do 1, 28, I can have 2, 14, I can have 4 and 7. Well, I know that I want the greater value to be negative. So I can have 1 and negative 28, 2 and negative 14, or 4 and negative 7. If I add them up, the one that matches is going to be this 4 and negative 7. So if I fill that in, I'm going to have a positive 4 and a negative 7. My final answer looks like negative 1 times the quantity x plus 4 times the quantity x minus 7. Let's FOIL this one out just to check our work. When I FOIL those inner pieces, I get x squared minus 7x plus 4x plus minus 28. And when I combine, I get x squared minus 3x minus 28. If I go back and put in that minus 1 on each piece, I wind up with a negative x squared plus 3x plus 28, which matches my original expression. One homework problem to go over here. I want to think about y squared minus 17y plus 72. And now this time I'm using y instead of x. It doesn't matter. That's just a placeholder for my variable. And it matches. The squared piece is the same as the singular piece. So this is still in that same form. If I think about my greatest common factor, there's nothing I can pull out of all three pieces. So I'm on to thinking about factor pairs that multiply to make 72 and add up to make a negative 17. Well, in this case here, I see that I have positive for my multiplication, but negative for my sum. So that tells me that I'm going to have two negative pieces here. I want to think about the factors that multiply to make 72. So I can have 172, I can have 236. Going through the factor pairs, I'm going to use 8 and 9. And I know that they're both going to be negative. And so many of you can skip the step here. You don't need to list out all the factors and find the pair if you're starting to pick up the pieces here. My negative factors of 8 and 9, I have my factored form. Now your textbook asks you to check using a graphing calculator. You can check using Desmos. You can type in and type in your factored form and have it convert for you. You can choose to do it that way. I think the best way to check your work still is either the FOIL or the area model. So if let's see, I think I foiled. Let's area model this one. I keep wanting to write X because I'm so used to writing X, but in this case we have Y, and we have a -8, and we have Y and a -9. When I area model this out, I get Y, can't see yellow. I can't see yellow. Maybe you guys with your young eyes can see yellow. Y squared minus 8Y minus 9Y plus 72. When I write it out in standard form, that turns into Y squared. I have a -8Y and a -9Y, so I have a minus 17Y and a plus 72. It matches my original equation. Last homework problem, and this one I'm not going to give points for on the key, but I just wanted to practice with it again. Jerome and Charles both solved to factor x squared plus 6x minus 16, but they got two different answers. Jerome found the two factors to be x plus 2 and x minus 8. Charles found the two factors to be x minus 8, or x minus 2 and x plus 8. So what I see here is that both students identified the factors as being 2 and 8, but they have different positives and negatives. So what I would do to check the work in this situation is I would start with what they have already. I'm going to FOIL it out and see which one matches. So if I FOIL out Jerome's, I get x squared minus 8x plus 2x minus 16. When I combine my like terms, I get x squared minus 6x minus 16. That doesn't match, so Jerome is definitely wrong. That middle piece does not match. Let's try Charles now. If I FOIL out Charles's work, I get x squared plus 8x minus 2x minus 16. When I combine those like terms, I get x squared plus 6x minus 16. That matches the original equation, so Charles is correct. Those middle terms there are important. We need to think about our positives and negatives when we're combining our factors here. Homework tonight is a short one. There's 11 problems there, and we've done 2 of them already in this video, so you've got a great start on it. When you're done, check your work, submit your score through the form, and then take some extra time today to work on Delta Math. The next video is going to talk about the second half of 8.6, so it'll be more problems from the same lesson, but we're going to focus on a slightly different skill. Thanks, guys.